Assalamu alaikum. So in the last part, we saw how to actually use the completing the square method to get the answer of a quadratic equation like we got here. And what is a completed square form, which would be in this case x plus 1 whole square is equals to 16. That would be our completed square form, since we have a completed square term of x, or in terms of x we have a completed square on the left hand side. So this is called a completed square form. Now in this video I'll be discussing how we can get to that completed square form using this general form of quadratic equation and manipulating it in such a way that we get to the quadratic equation or the completed square form of the quadratic equation. So let me write down the general form of the quadratic equation, which would be a and then termed x square, which would be then plus b and then an x, and then I would have a c here, which would all be equal to 0. Okay, now we have the quadratic equation, the general form of the quadratic equation here, and notice that here we have a term of x plus 1 whole square. Okay, so we know that if I'll use the next page for this. Okay, so we know that if we talk about we know this one thing, that if we have the term e plus f, I'll use e and f instead of x and y or a and b whole square. This is equals to e square plus 2ef. Let me do it a little bit more to the left. So what we know there is, if we have e plus f whole square, it is equals to e square plus 2ef plus f square. Okay, we know this. Okay, what we can see here is in the last part where we ended up with, we see that we have a completed square in the left hand side, and it is of the form x plus y whole square or e plus f whole square, in which case e is equals to x and f is equals to 1. Okay, so I would try to make sure to convert this into this form somehow. Okay, so that I can get on the left hand side this. Now let's try to manipulate this equation in such a way to get that. So it would be it would be a x square plus b x plus c is equals to 0. I would like to take this to the other side. The reason would be explained in the next steps. So to take this to the other side, I would have to subtract c on both sides. I'll do that in the next part. So it becomes a x square plus bx plus c minus c is equals to 0 minus c. This would cancel out, giving us ax square plus bx is equals to minus c. Okay, we got to this form of the equation. Now since I want this on the left hand side, I need to make sure see what I have as for e and as for 2 and as for f. Okay, since that is what I need. Okay, so first of all, it would be much easier for me if I take e is equals to x, and e square would be equal to x square. Okay, if I consider this case, so in this, to make it so, I'll have to eliminate this a somehow. Okay, I'm sorry, this x square would be of blue color, cyan color already. Okay, next to take the a to the other side, I'll have to divide the whole equation with a on the left hand side and then on the right hand side as well. Okay, so I'll do that. What I'll get is, I'll get x square, since I have an a here, I'll write down an a below it, plus b x, and it would be divided by a as well. Okay, the both terms on the left hand side would be divided by a, and it is all equal to minus c divided by a. I can just cancel out this a and this a here. What I'll get here is x square, which is plus b x over a, and all of this is equals to minus c over a. Okay, I've gotten to this form, and in this case I can see that x can be equated to e. Okay, what do I need next? I need this the coefficient of x, since we have e here. So the coefficient of x would be equal to 2f. Okay, so I'll do that. I'll consider b over a is equals to 2f. Okay, or rather b, I'll write down with all the colorings so that it does not get confusing. So b over a x is equals to 2ef. Since we know that e is equals to x, and as we have seen that x square is equals to e square, and then this would cancel out to give us x is equals to e. Okay, now we can see this to be true. Next, since e is equals to x, we can just cancel these out. Next, I can write b over a to be equal to 2f, and from here we can see that f is equals to f is equals to b over 2a. Okay, b over 2a. Okay, we can see that. Okay, since f is equals to b over 2a, I'll have to break this middle term, x square plus since I know that f is equals to b over 2a, I'll not break this middle term for now. I'll just keep it that way, plus b x over a. Now the reason I got this f is I need this f on the left hand side to compress it into this form. Okay, so to get that f, I'll just have to add an f square on the left hand side, and if I add a f square on the left hand side, I'll have to add the same f square on the right hand side. I'll do that here, plus f square is equals to minus c over a plus f square. Okay, now we know that f is equals to this, so I'll just add this squared. I'll just put this value into the f to get f squared. Okay, what I'll get here is x square plus b x over a bx over a plus b over 2a, since that is the value of that, and I would like to change the colors, over 2a whole squared, and this is all equal to minus c over a plus b over a b over 2a whole square. Okay, I've just added that to the both sides as I can do. Okay, next I'll just compress it into the form that we can see here. So it would become, since this is e and this is f, I'll just write it down as x plus b over 2a. Okay, I'll write it down as whole square, and this would be equal to minus c over a minus c over a plus b over 2a. Okay, now this is the general form for completing the square, and we can just put in the values of a, b and c in this equation to get the completed square form. Now, considering the equation that we had solved in the previous part, I remember that a was equal to 1, b was equal to 2, and then c was equal to 15, rather minus 15. Signs are important, so it was minus 15. I'll just put in those values here. So it was x plus I'll have to do it a little bit up. So it was x plus the value of b, which was 2, and all of this was divided by 2 and the value of a, which is 1. Okay, and then all of this whole squared is equal to minus c, so minus and then minus 15, in which case minus and minus would cancel out. All of this divided by a, which was in our case 1, and then this plus the whole squared form of b over 2a, or rather it was 2 for the b, and then for the a we'll have 1 here. Okay, now we can clearly see 2 would cancel out with 2 to give us 1, and then here 2 would cancel out to 2 to give us 1, and 1 squared is equal to 1. So what we get at the end is x plus 1 whole square. All of this is equal to 16, since 15 plus 1 would be equal to 16. So we get the answer that we got in the last part by just using that formula that we have just derived. Okay, so this was how we use the completed square form. How we have derived a formula here which can be used for any quadratic equation to get the completed square form of that quadratic equation. This can solve all the problems for the quadratic questions, okay, for all the quadratic equations, and get the values of x for every quadratic equation. Now in the next part we will be getting a formula which would be the quadratic formula, which would directly give us the values of x, where we would have x is equals to something something, and it would give us the values of x, and we would derive it from this formula right here that we can see. This formula would be used to get that quadratic formula. So hopefully see you guys in the next part, and if you have any question regarding today's explanation and today's derivation, do comment down below. All right, Allah Hafiz.